I'm going through the questions for normal distribution for the Canvas review assignment. The mean score on a test for your statistics class was an 82 with a standard deviation of 7 points. What is the z-score for an A on the test described above, which has a mean score of 82? Assume that an A is 93. Type in your answer rounded to 2 decimal places. So then I've got this reminder of what a z-score is, and I've actually kind of walked you through the process to find that answer. Okay, so z-score for an A on the test would be the data value, which would be 93, subtract the mean, so the mean is an 82, so 93 subtract 82, and then we divide by the standard deviation of 7. So 11 divided by 7, that gives us a decimal answer. Let's see what that is. So I used my calculator and I got an answer 1.57142857. Okay, so with a z-score, I would say just like 1 decimal or maybe 2 at the most is enough. When I first wrote this quiz, I set it up so that if you answered 1 decimal, you got it wrong, but if you did more than 1 decimal, like 2 decimals, you got it right. So I think I've adjusted that so it shouldn't matter anymore. But anyway, I have it set to be 1.57, but now I've also adjusted the error margin so that if you type in 1.6, it should still give you the points. Okay, on a college entrance exam, the mean was 70 and the standard deviation was 8. If Helen's z-score was negative 1.5, what was her exam score? So now we're going to go backwards. So her exam score we're going to call x, and x minus the mean would be x minus 70, and then we divide by the standard deviation 8, and we get the z-score negative 1.5. So I'm still using the same exact equation from the last problem. I just have to solve for a different piece of it. I'm going to cross multiply. X minus 70 equals 8 times negative 1.5. So we get a negative 12. So now I'm going to add the 70 to each side. And x should equal 58. So that if we plug that back in like this, 58 minus 70, we would have 12. 12 divided by 8, or negative 12 rather. And negative 12 divided by 8 would be our negative 1.5. So the score with a z-score of negative 1.5 would be 58. On a nationwide math test, the mean was 65 and the standard deviation was 10. If Robert scored 81, what was his z-score? So 81 is his score, subtract the mean, divided by 10. So again, we're just going to use a calculator to find a decimal. So that's actually pretty easy to do without a calculator because we get 16 divided by 10, which is 1.6. We don't even have to worry about extra decimal places there because there aren't any. We've now seen 3 problems of this same type of idea. Okay, the heights of 5th grade boys in the USA is approximately normally distributed, with a mean height of 143.5 centimeters and a standard deviation of about 7.1 centimeters. What is the probability that a randomly chosen 5th grade boy would be taller than 157.7 centimeters? So that's where I like to draw a chart. So I've got the mean in the middle, 143.5, and then I have my standard deviation of 7.1, so I'm going to add that. 143.5 plus 7.1, so I'm adding my 7.1, so I get 150.6. I want to get this up to 157.7, so I'm going to add it again, and that actually takes me there. So 157.7. So just a reminder of the standard deviation percentages. Remember that in here we have 34 and 34% of the data, approximately, for a total of 68. You can totally use this chart on your test. And then over here we have, is it 13? Why am I not remembering? Yes, I had to look it up. So 13.5 here, and 13.5 here. And then the rest of this is 2.5. But if we want to split that up into another standard deviation, so that this is like a z-score of 0, and a z-score of 1, and a z-score of 2, and a z-score of 3, then this section here would be 2.35, and then z-score of 3 and beyond is only 0.15%. Okay, so our 157.7 is sitting here at our second standard deviation, or a z-score of 2. So taller than that would be above. So we have this portion right here would be above. So together 2.35 and 0.15 is 2.5%. So that is the answer we would select. All right, some more. Which grade is better, a 78 on a test whose mean is 72 and a standard deviation of 6.5, or an 83 on a test whose mean is 77 and standard deviation is 8.4? So I basically took any explanation you wanted to here, but if you compare z-scores, then the z-score of the lower test score is better, because overall more people did better on this test, and so a higher score on this test means more because compared to everyone else who did better. So I don't know if that makes sense. So you can just calculate the z-scores the same way that we did in the first 3 problems and compare those and just write an analysis about it. Okay, last one. Assume that the mean weight of a 1-year-old girl in the US is normally distributed with a mean of about 9.5 kilograms and a standard deviation of approximately 1.1. So if we add 1.1 this direction, we'd have 10.6, 11.7, 12.8. Then if we subtract our 1.1 the other direction, we would have 8.4, 7.3, 6.2. Okay, so what's the probability we'll have less than 8.4 kilograms? So just add those percentages together. So 2.5 plus 13.5, which is basically 50%, subtract 34%. So that would be 16. Change this to my pen. So 16%. Okay, and then between 7.3 and 11.7, between 7.3 and 11.7 would be this portion right here. So altogether that adds up to, let's see, we've got 27 plus 68. That's the, sorry, I should be able to do that in my head. Is that 97%? So we've got the 2.5 this way and the 2.5 that way, so that's 5% total. So that would be 95%, correct? Okay, so then the last one would be more than 12.8. That's going to be a very small amount, because just these outliers, basically, when you go beyond the 3rd standard deviation, it's more or less outliers to the data that don't really fit. So this would be an outlier for that to be true. So seriously, 0.15%, like not 1.5, not 15%, 0.15% probability of that being the weight of the chocolate. Okay, I hope that helped. Go in and get a perfect score on that assignment.